So it is electricity. Electricity. Right. Electricity. It's a type of energy. It's a type of energy. Electric energy, which a very important energy, which is very much merged, connected with our day-to-day life. It's something like without this energy, nothing we can do alive because that much we have been merged with this electric energy. Okay, so we are using that energy throughout our day-to-day life, right? So some of the theories related to electricity is what we are going to speak about in this part. That is, we're going to start up with some small basic ideas about this, which you have already learned in the previous grade. Okay, some of the ideas you have already learned. So as for recap, and we will go up with our lesson, right? So initially, when you learn about electricity, some basic symbols you must know, right? There are some symbols given here, right? Have a look. Starting with open switch, closed switch. Okay. Likewise, lamp, voltmeter, ammeter, resistor, different points are given here. So we have to be very familiar with these symbols because we have to draw circuits, we have to recognize the circuit diagrams. So in circuit diagrams and all, we can't draw the exact image or exact picture of the gadgets that we are using. We have to symbolize them. So these symbols are very much important. Okay. So let's take the topic on a writing book. Go to a writing book. So the topic electricity. Electricity. And right there, electricity. Electricity refers to refers to either stored, either stored or flowing, either stored or flowing electric charges. Electric charges. Either stored or flowing electric charge. One next line and write. Accordingly, accordingly, there are two types as there are two types as static electricity, static electricity, and current electricity. There are two types as static electricity and current electricity. Static electricity and current electricity. Okay, so static electricity refers to the stored electric charges. Maybe because of rubbing each other, it forms up electric charges. Okay, there will be a track. And dynamic electricity or current electricity, that is the flowing electricity. So basically, we are going to speak in this chapter about the current electricity. Okay. So when you cover this current electricity, current electricity, it is the flowing electric charges from one point to another point, right? So to learn about these, we must know the electric circuit symbols, diagrams, and all some basic properties are there. Okay. So let me start up with the circuit diagram first, and then we will be taking the properties and the factors over there. So when you come for a open circuit, open circuit. Let's say I'm going to connect like I thought the symbols are important. This is the lamp, okay, lamp or the bulb. A very simple setup I am going to mark. And here I have the switch. And the switch is open. You see that the switch is open. And I am connecting it with a dry cell. I am connecting it with a dry cell. Right? So this symbol is given for dry cell. This is the switch and an open switch, and this is the lamp. Now in this case, okay, there is a voltage here. Longer terminal is called the positive terminal and the shorter terminal is the negative. So between this positive and negative, there is a potential difference. Potential difference. Okay, but they are we will learn. So this potential difference is what given as the voltage here. Potential difference is what given as the voltage here. You can see. Okay. So in an open circuit, there is no current. There is no current. In open circuit, current is zero. I is current. I is current. Okay. And when you're gonna take a closed circuit, current is not zero. Current is not zero. There is a current flow. So how do we take that? Here, the same bulb. You should not keep spaces among this like this. If there is a space like it refers to the wires are not connected. So it's a wrong connection there. Okay. And here now the switch I'm marking like this. I have closed. Can you see that switch is closed? And then I do have the same terminals. Okay. I have the same terminals here, right? Shorter terminal and the longer terminal. And now the same voltage is given there. What happens? What happens when in such a closed circuit you take from the potential differences from the negative terminal, electrons will be flowing out. Electrons will be flowing out. Okay, so we told that electric charges are there. So basically, the electron, when you come for a conductor means which can conduct electricity. So conductor contains electric charges minus electric charges. Basically, they are the electrons. So imagine these are conductors. We have learned about the metal conductors. Basically, the metals they do have electrons in their outermost shell. You learn it in chemistry. So they have some electrons which can be removed out because they belong to group 1, group 2, group 3 elements basically the metals are. So they have such electrons which can be removed out. So these electrons will be coming out of the shell and will be staying between the atoms within the metal conductor. So these electrons are readily available to move. They are randomly moving free electrons. So when these negatively charged, randomly moving free electrons are there within the conductor and you are going to connect up with a voltage supply, what happens is these negative charges will be repelling. So you are giving a negative terminal here, right? And the metal conductor is having negative charges, right? So negative to negative repels and the negative charges from here will be moving. So the negative charges are moving out from the negative terminal. So you can see here electrons. Okay, they flow from electron flows from negative terminal to positive terminal. This is the pathway of electron. Goes across and it comes back to it comes back to positive terminal. So electrons flow from negative terminal to positive terminal. While conventionally the current, when the electrons are flowing from negative terminal to positive terminal, conventionally the current will be sent out from the positive terminal. I we refer to as, so I moves on light and passes in the opposite direction and comes back to the minus terminal. So you can see accordingly current flows okay, from positive terminal to negative terminal. So while the electrons are flowing from negative terminal to positive terminal, current is flowing, the conventional current is flowing from positive terminal to negative terminal, positive terminal to negative terminal. So this is how current flows. This is the direction that the current flows. So the bulb turns on, the lamp lights up. The lamp lights up. So this won't happen when you come for an open circuit. So that's the difference between open circuit and a closed circuit. So all the current related stuff that we are taking up here related to the closed circuit. It is switch on. It should be a closed circuit. Closed circuit. Okay. So now here there are some key words that we are supposed to learn. Okay. So initially we learn about the word charge. Okay, the electric charge. Okay, electric charge. So what is this electric charge? What is this electric charge? You see here, we told you now electrons are what we do have here. These electrons are negatively charged particles. Okay, so they can transfer. They can transfer energy throughout the wire. They can transfer energy throughout the wire. So this energy is what electric energy. Okay, and you can read there. Electrons are negatively charged particles and they transfer energy throughout the wires as electricity. Charge is a property of a body which experiences a force in an electric field. So what is called a charge? It is experiencing a force in an electric field. So where the electricity is connected. So charge is measured by capital C. Charge is measured by capital C. Capital C refers for coulombs. Coulombs. And the charge is Charge is symbolized by capital Q. Capital Q. So you see what is called a charge. Charge is a property of a body which experiences a force in an electric field. Force in an electric field. So what is called a charge? Charge. You can see there. It is a property. It is a property of a body which experiences a force in an electric field, a force in an electric field, in an electric field. Some of them are negative charges, some of them are positive charges. So here, electrons are negative charges. Okay, electrons are negative charges, right? And you see, we are symbolizing the charges by capital K. You have to remember these points. Capital K. We are symbolizing the charges by capital K. Okay. So Q refers to charge. Q refers to charge. Symbol of charge. And what is the unit used to measure? Okay. What is the unit used to measure? We write it as measuring unit. Measuring unit, we term it as coulomb. And the unit symbol, what is the unit symbol? C. Capital C. Capital C. And this coulomb is actually taken to find out to measure the total number of electrons. Now the electrons are very small, right? So electrons are very, very small. So when you're gonna count the number of electrons, because the charges, number of charges means number of electrons, it's very hard to count since it's a long value. So as a standard, we are using the coulomb. We are using the word coulomb to give the charge. And it is supposed to be, it's measured to be 1 coulomb. 1 coulomb is equal to somewhere around, can you read that number? Can you read this number? See here, 62500000, it goes on. Can you read the number? Sorry? How much is it? 6.25 into 10 to the power 18. 6.25 into 10 to the power 18. So you see, it is said to be 1 coulomb is equal to 6.25 into 10 to the power 18 electron. So it is easy for us to write in the standard form, in the scientific notation. So you can see here, 1 coulomb is equal to 6.25 into 10 to the power 18 electrons. That means if you have 2 coulombs, it refers to 2 into 6.25 into 10 to the power 18. If you have got 10 coulombs, got to multiply that by 10. So accordingly, Coulomb is equal to 6.25 into 10 to the power 18, 10 to the power 18 electron. Did you understand that point? Okay. So that is why I told you it is a long value. Every time we can't use, so we measure it as 1 coulomb. So by the coulombs only we are measuring the charge. By the coulombs only we are measuring the charge. Now, what is the connection of these charges with the electric current? Now, every time there will be charges moving out, right? There will be charges moving out. Now we have to count. Usually we are getting a measuring, we are getting a physical quantity for a unit time, right? So the unit time means 1 second. 1 second. For 1 second, how much are they? So likewise, we also what we do, we find out how many charges are moving out for a unit time. How many charges are moving out per second for a second time. So number of charges flowing out for a unit time is what we term as electric current. Is what we term as electric current. So electric current refers to charges flowing out, charges passing out for a unit time, for a unit time per unit time. You understand? So accordingly, that is the connection relationship between the charges and the electric current. Okay, anyhow, here as an example, hence 2 coulombs contain 2 into 6.25 into 10 to the power 18 electron. I'm writing E as electron. Okay. Then 10 coulombs of charges refers to 10 into 6.25 into 10 to the power 18 electrons. 10 to the power 18 electrons. So that is the idea of this coulomb. That is the idea of this coulomb. Okay. Right. Now, it's about the charges. Now, what is called the electric current? Electric current refers to what is the amount of charges flowing out for a unit time. Amount of charges flowing out for a unit time is called electric current. Electric current. Okay. So how do we write that? We write it in this way. Electric current is the rate of flow of electric charge. So we can say it is the rate of flow of electric charge. Rate of flow of electric charge. Electric charge. Now, whenever the current is flowing out, guys, it would be taking the energy out. That means there will be energy transfer. A work is done because the people are moving out means there is a work done, right? So work done. That means energy is transfer. Energy is transfer. So accordingly, we can build up a formula between the current and the charge here. What is it? The charge equal to, or else the electric current is equal to electric current is equal to, okay, charges. How many charges are carried over a unit time dividing by the time. Dividing by the time. So I is equal to Q over T. I is equal to Q over T is what the formula we are building up here. I is equal to Q over T. I is equal to Q over T, where the Q is measured in coulombs, time is measured in seconds. So I should be coulombs per second. Coulombs per second. How many coulombs are there for a second? So this is written as amperes. So what is the unit we are giving for current? The unit we are giving for current is amperes, capital A, capital A. Right? So see, this is the formula, this is the equation we are using to find out the electric current. Electric current. So this is given in word and that is given in symbol. So accordingly, electric current, when you are going to take, electric current is symbolized by symbol of current is capital I, and the measuring unit is ampere. Measuring unit is ampere. And the symbol of amperes, capital A. And then, so we are using an equipment to measure this. Okay. Tool to, or else measuring tool, measuring equipment.
What is the measuring equipment? Measuring equipment is called ammeter. And the symbol of ammeter is this. This is the symbol of ammeter. Okay. So that is a symbol. So everyone has a symbol, equipment and the symbol. And the symbol. So that is about the electric current. That is about the electric current. Did you understand that? Right? So shall we take a note? I have given you in short. Right? I didn't give two long statements. Only the definition is there. Apart from that, we wrote in short summarizing. Okay. Shall we note this down from here? I can start writing. Hope you're writing. Are you done? Not yet, huh? Hurry up. Are you done? Yeah. Okay. Then we are done, huh? So accordingly, you can see there I is equal to Q over T, Q is equal to I into T. Q is equal to I into T. That is how we find out the current. Okay, I is equal to Q over T. Right. So what it means now, accordingly, you can see 1 ampere is the current that flows in 1 coulomb of charge passes a point in a circuit in 1 second. So what do you mean by that? When you're gonna take this, okay, I is equal to Q over T. That means Q is equal to I into T. Q is equal to I into T. If you're gonna take it as a formula triangle, this is how it works. You know, this is the division, and this is gonna be the multiplication here, right? So as to rearrange, I is equal to Q over T. So that means Q is equal to I into T. So I can write Q here. Q is equal to I into T. I into T. So how do we rearrange the formulas? How are we rearranging the formulas? Rearranging the formulas goes, so Q is equal to I into T. So Q is equal to I into T. You can see. If you want to find out I is equal to Q over T. I is equal to Q over T. Okay. And then T is equal to Q over I. Q over I.
right? So these are the rearranged formulas. And what is the definition of 1 ampere? What is the definition of 1 ampere? So when we are defining 1 ampere, when we are defining 1 ampere, it is the current that flows when 1 coulomb of charge passes a point in a circuit. Okay, so let's write this down first. Let's write this.
Right there. Definition of 1 amperes. Definition of 1 amperes. Definition of 1 amperes. Right there. 1 ampere is the current. 1 ampere is the current that flows. 1 ampere is the current that flows when 1 coulomb of charge, when 1 coulomb of charge when 1 coulomb of charge passes a point in passes a point in passes a point in 1 second time, passes a point in 1 second time. Okay, 1 second time. Right. So you can see here the way the ammeter is connected. Ammeter we are using to measure the current, right? So ammeter is connected in series. Remember, ammeter should be connected in series. So always ammeter must be connected in series. Okay, and that is an open switch, right? Open switch. So in that, once you close it, you can measure what is the current passing on. Okay, remember ammeter is connected in series. Okay, ammeter is connected in series. Right? Right. Potential difference. Potential difference. So let's write the potential difference. Take the topic potential difference. Potential difference. And write there potential difference. Yeah. It is a measure of, it is a measure of energy. It is a measure of energy. It is a measure of energy. I can write from here. Per unit charge. per unit charge transferred between 2 points in a circuit. Transferred between 2 points in a circuit. So these 2 points out, we take it as the plus and minus, okay, positive terminal and negative terminal. Transferred between 2 points in a circuit. Write in the next line. A potential difference of 1 volt means, a potential difference of 1 volt means that 1 joule of work is done. 1 joule of work is done. 1 joule of work is done per coulomb of charge. Per coulomb of charge. Per coulomb of charge. Okay. And can you see here the voltmeter? So how do we connect the voltmeter? Now voltmeter is what the equipment, like ammeter here. Voltmeter is what we are using to measure the voltage. Voltage or potential difference. So what is this potential difference? That is the difference between their energies. Okay. So between 2 points, it is measuring the energy transfer. Energy transfer. So positive terminal is said to be the high potential difference. Negative terminal is said to be the lower potential difference. So always remember high potential difference to lower potential difference, only the current passes. High potential difference to lower potential difference, only the current will be passing on. So high potential to low potential, current passes. So you see here, same like diagram. We're gonna take the potential difference. This is the setup, let's say. It is a lamp. This is plus minus, and here high voltage potential difference is measured. It is symbolized by V. High voltage, and this is low voltage. Minus is low. Plus is high, minus is low. So higher voltage to lower voltage only the current passes. So the current is passing across this. So this point is connected to the higher voltage and this point is connected to the lower voltage. Can you see that? This point, here the point, it is connected to the positive high voltage. This is connected to the negative low voltage. Low voltage. Okay. So this is how it's connected. And since it is just a lamp, we don't want to consider about the plus minus terminals of the lamp itself. Let's say if it is an LED, it has positive negative terminals. Then when you are connecting an LED you can buy from the market side. So when you are connecting an LED for a dry cell, this is the symbol of a dry cell. No? So for a dry cell, if you are connecting an LED with it, LED does have two terminals. Longer terminal is positive, shorter terminal is negative. When you are taking an LED does have two terminals. Longer terminal is plus and shorter terminal is minus. So what are you supposed to do? Always you have to connect the longer terminal with the positive and shorter terminal with negative. Longer terminal with positive and shorter terminal with negative. Then only it will be working. Otherwise it won't work. And here the voltmeter. Let's say you want to connect the voltmeter. Voltmeter you have to connect somewhere parallel. So here I'm connecting the voltmeter parallel to the bulb. So what is the voltage measured here? Voltage of the bulb. Voltage of the bulb. So you see voltmeter is connected parallel. Voltmeter is connected in parallel. And whose voltage we are measuring? Here we measure the bulb's voltage. Bulb's voltage is measured. Okay, the bulb's voltage is what measured here. And moreover, the symbol of, and you're gonna take the symbol of voltage is V and the measuring unit and its symbol. Measuring unit is volts and the symbol is also taken V, right? And the measuring equipment, right, is voltmeter and this is the symbol of voltmeter, right? It is a symbol of voltmeter, right? Shall I write this? Done. This part to be written, okay? Okay, done, I guess. Right. Now, you see, the initial parts are very easy, okay? Now we learn now whenever there is a potential difference and it transfers energy when the current is passing on. So what is the relationship between this energy transferred and the charge moved? You can see there. We can find out the energy transferred as the product of Q and V. What is the amount of charges moved into potential difference? Into potential difference. So E is equal to Q into V. E is equal to Q into V. Let's write that down. Energy transferred equals, because earlier we learned, right, how much energy is transferred. Can you see that? It is a measure of energy per unit of charge transfer. So how much energy is transferred between 2 points? So this energy transferred is what we are finding out using this equation. Very simple equation. Okay. E is equal to Q into V. So what you are learning here, guys, I'm explaining more to subject the areas clearly. So theory, the summary is very easy. What is the summary of the previous part? Q equals IT. I is equal to Q over T. And here E is equal to Q into V. E is equal to Q into V. And the definitions you have to remember. So let's write this down. Here too we can build up the formula triangle. E is equal to Q into V is equal to Q into V. So rearranging the formulas, E equals Q into V. You want to find out E, Q into V. You want to find out Q, E, this division, E over V. You want to find out V, V is equal to E over Q. E over Q. And take those two questions and give me the answers, please. Write down those two questions. Right? Could you find out the answers for that? What are the answers? What is the potential difference between 2 points if 2 coulombs of charge shift for 4 joules? So how do we find out the potential difference now? E is equal to Q into V. So you want to find out the potential difference, right? So V is equal to E over Q. E over Q. This is the first question. So how much is E here? 4 joules. Energy transferred is 4 joules. What is the charge? 4 joules over 2 coulombs. 4 over 2. 4 over 2. So V is equal to E over Q. So 4 over 2, it's 2, and the voltage is measured in watt. 2 watts. Very simple. It's 2 watts. 2 watts. And what about the second question there? How much energy is transferred when 3 coulombs of charge moves through a potential difference of 6 watts? Now you want to find out the energy transfer. Q into V. How much is Q here? Q is given as 3 coulombs into voltage is given 6 volts. So 3 into 6, it is 18. E is measured as joules. E is measured as joules. Okay. So Q is given in coulombs, voltage is measured in watts. So the energy should be given in joules. Joules, right? Easy formulas. Right. So let's take the next point. We learned about electric charge, electric current, potential difference, and then the next wording, resistance. Resistance. So what is this resistance? So let's say you are moving on a street. Again, fast you are moving. But by the way you are moving, you can see on the street there are some stones, bushes, stones, rocky particles are there. What happens for your speed? Your speed reduces, right? You can't move at the same speed. Your speed will be reducing. Your speed will be reducing. Why is that? There are obstacles. There are barriers on your path. Likewise, okay. To the current flow, to the flow of current, there are some barriers given naturally by the conductors. Artificially also we can make, right? So this natural obstacle, barrier for the flow of current is what we term as resistance. Resistance. So if the barrier is increasing, current flow will be decreasing. That means the resistance, when it is increasing, the current flow will be decreasing. That means if you reduce the resistance, you can increase the current flow. So this proportionality we term as inversely proportional. Inversely proportional. Okay, so inverse proportion is there between these 2 points. So let's write there resistance. Resistance let's write that down. Resistance is a property resistance is the property that opposes resistance is the property that opposes the flow of electric current. The flow of electric current. The flow of electric current. Resistance is the property that opposes the flow of electric current. Flow of electric current. Okay. Right. What is resistance when we are taking resistance? Okay, it is naturally also given, artificially also given. So when we take the symbols, symbol of resistance, symbol of resistance is capital R. And measuring unit, we term it as ohms. The symbol is, this is the symbol. Okay, we name the symbol as omega. What omega? Omega. Omega is the symbol. Omega is the name of the symbol. So ohms we refer to it. Ohms. So what is the measuring equipment? Measuring equipment we term it as ohm meter. Ohm meter. Ohm meter. Right? What is the equipment? In circuits, when you come, the resistor does have several types. Okay. Types of resistors. Resistor is the equipment that is giving you the property of resistance. That means, so I told you right, naturally also there is a resistance. So natural wires when we are taking, resistance is there. And basically in our domestic circuit, what is the wire we are using? We are using copper wires. Why copper wire? Copper wire does have a very lower resistance. That means a big current we can pass, the needed required current we can pass at a lower force, energy, right? So resistance is less there. And artificially also we can connect the resistance. How do we connect? That the resistance given Okay, resistors given, electric gadgets you are connecting, we term them as resistors. And these resistors, when you are taking, there are three types of resistors. There are three types of resistors. What are the three types? Basically, three types. Number one, we term it as fixed resistors. Fixed resistors. So, fixed resistors means they do have a fixed resistance value. They do have a fixed resistance value that cannot be changed. So natural, these are natural, and artificially also we can give. So how are we supposed to show them in the electric circuits? So this is the symbol we are giving for them. You could have seen in electric circuits like this, either this or like a zigzag. So this is the symbol we are giving for fixed resistors. And number two, variable resistors. Variable resistors. So variable resistors means a range of resistance value. A range of resistance values. So for an example, like 1 ohm to 100 ohms. 1 ohm to 100 ohms. 100 to 500 ohms. That means within that range, we can increase and decrease. 1, 2, 3, 4, 5, 6, 10, 20, 30, up to 100 we can give. Or we can reduce according to our requirement. Okay. So a range of resistance values can be given by ohm variable resistors. Variable resistors. There are different types of variable resistors. I hope you have done with this. Okay, you can write with me. You can write with me. And what is the symbol we are giving? Look at the symbol. Very easy to identify. So can you see the same symbol as above I grouped, right? Now, variable, how do we show? An arrow here. Across arrowhead, we have to show them. Okay, so this is variable resistance. And the third one, light dependent resistance. We term it as LDR. LDR. So, resistance here depends on the light intensity. Okay, how much light falling on it, accordingly it changes. So here the light intensity is inversely proportional to resistance. Okay, so light is inversely proportional to 1 over alpha to the resistance value. To the resistance value. What it means? It means if light is increased, resistance decrease. If light is decreased, resistance increase. If the light is increased, resistance decreases. If the light is decreased, resistance increases. Okay. So what is the symbol we are giving for this? Same like I'm drawing. You can see. How is it going to change? Light dependent. Depending on the light. We show by two arrowheads like this. Okay. Two arrowheads we are marking in this way. To show that it is depending on the light. Depending on the light. All theories. All theories. And number 4. Thermistors. Thermistors, when you are taking, here the resistance value. Here the resistance value is depending on, okay, depending on the temperature. Resistance depends on the temperature. Resistance depends on the temperature. Resistance depends on the temperature. Okay. How is it happening? Here, the temperature is directly proportional to the resistance. That means when the temperature is increased, resistance increase. When the temperature is decreased, resistance decrease. Resistance decreases. Please write it down. Now, how do we give the symbol of this thermistor? Same way, let me take. You can see the same is added up with sum. So look at this today. You should not confuse it. So this is a straight arrow here. Okay. And what we're gonna do here, it is a sort of line like this. Can you see? Okay. So this is thermistor. It is thermistor. And rheostat is an example for variable resistor. Okay. For rheostat also the same symbol can be given. Rheostat is the electrical equipment that we use as a tool that we use as a variable resistor in our school laboratories. Are we done? Give me a thumbs up once we're done.
Running, huh?
Sharon, are you done? Yes. This is done now. Okay. So let's take the next point now. The relationship between potential difference, current, and resistance. What a topic there? The relationship between the relationship between the relationship between the potential difference, current, and electric resistance. Potential difference, electric current, and electric resistance. Right? So what is it? What is it? Right there, what is given? Potential difference is equal to current into electric resistance. Potential difference is equal to current into electric resistance. Potential difference is equal to current into electric resistance. Electric resistance. Current into electric resistance. Okay. And right there, V equals I into R. V is equal to I into R. V is equal to I into R. Right? So here you can see V equals I into R. When you take I is measured in, you can write this as well, amperes. R is measured in ohms. How do we read this? Ohms. Okay, ohms. So V is measured in watts. V is measured in watts. All right. So the formula triangle, how would it work? V is equal to I into R. V equals I into R. I is equal to V over R. R is equal to V over I. V over I. Right? And this is one of the important equation in this electric part. V equals IR. V equals IR. Right. So basically about this equation, there are some theories we have to take. Okay, and we have to work with some questions as well. So you see, V equals IR. In this, V is equal to I into R. The relationships you have to learn. What are the relationships here? Then look at this. If V is a constant, then I and R are inversely proportional. Inversely proportional. What do you mean by that? When you increase resistance, current decreases. When you decrease resistance, current increases. Current increases. Okay? Inverse proportion. Inverse proportion. And number two. Let's say if the resistance is constant, then voltage is directly proportional to current. That means you increase the voltage, current increases. You increase the voltage, current increases. You decrease the voltage, current decreases. Current decreases. So you know these are not to be memorized. Okay, don't ever try to memorize it. I told you already earlier. Find out the method to get it. So methods are what I am teaching you. Okay. So if V is constant, these two are direct inverse proportion. R constant, you can see both of them are either side of equal mark, directly proportional. And let's say I is constant, then V and R also either side of the equal mark. So if I is constant, V is directly proportional to resistance. You increase the voltage, resistance increases. Or else you increase the resistance, voltage increases. You decrease the resistance, voltage decreases. Voltage decreases. Okay. So these are the relationships here. So especially related to the voltage and current, when R is constant, when R is constant, we are drawing a graph here. So the graph related questions also come. Okay. We take point by point. So let's say I'm going to take the voltage and the electric current graph. Voltage and electric current graph. Can we see the graphs here? Okay. Actually, this is the way the graph goes. If you are going to take the potential difference here in watts and the current in amperes. Current in amperes. You know, since this particular part we're gonna take, this is the part we are going to take. Okay. If R is constant, V and I are directly proportional. Direct proportion means always remember it should be a positive gradient. Should be a positive gradient. So you can see it's giving you a positive gradient. A positive gradient shows you both of them are directly proportional. When voltage you increase, current increase. So you can see when, let me take like this. When the voltage is increasing, current is increasing. So you can see here, when the voltage is increasing, current is increasing, right? Both the same. Okay. So the voltage is increasing, you can see, voltage is increasing, current is increasing. Current is increasing, right? So this is the usual graph that we are taking, right? So when you take this for a fixed resistor, for a fixed resistor, you can observe here, either side it will be a positive gradient. This is a positive gradient here, and this is a negative gradient here. Okay, to the negative side. All right. So that means in a fixed resistor, whenever you increase the voltage, current increases. Whenever you decrease the voltage, current decreases. There is no change in a fixed resistor because resistance is constant. Fixed resistors means now we learn, right? Fixed resistance means permanent resistors. They can't change their resistance value. So always the resistance is same until they are getting totally damaged, right? So resistance value being constant means as far as R is constant, you increase the voltage, current increases. You decrease the voltage, current decreases. So that both the sides it happens to be the same. But when you come for a filament bulb, have a look at the second diagram. In the filament bulb, you can see when the potential difference is increasing, current is also increasing. But after a maximum value, you keep on increasing the voltage. Potential difference you are increasing, but the current is not increasing. Current is not increasing. So can you see here very quietly it is increasing? You can see it's increasing. You know, both the sides increasing, right? So it's increasing. But can you see the curve is not a I mean, the graph is not a straight line like this. It's not a straight line, but rather what it shows you here, it is showing you something like this. Can you see? It's a curve going on like this, right? It's a curve, a downward curve, right? Remember, Pute, a downward curve refers to increasing rate is decrease. Vadivana pramane adu venu. Understand? Vadivana pramane adu venu. Increasing rate is decreased. Okay, increasing rate is decreased here. So the other side also you take increasing rate is decreased. So it is an S-shaped graph, a sigmoid graph we see. So an S-shaped sigmoid graph is given for filament bulb, And the same thing when you're gonna take for a semiconductor, what happens is semiconductor, remember, it is not a conductor, it is not an insulator. Conductor means it can conduct electricity. Insulator it can't conduct electricity. So what is the gap between them? Bridging apart. Some conductors, some materials are there which can conduct a very small amount of current. They are called as semiconductors. Okay. But to start flowing current, a minimum voltage should be provided. If not, it won't. Though you are properly connecting, minimum voltage is not given means it won't work. So, until the minimum voltage is given, you can see here it is a negative value, here it is a negative value, and then you keep on increasing the voltage, even above 0. Okay. So above 0 it's 1, 2, 3, like 0 0.1, 0 0.2, 0 0.3, like you are increasing the voltage. Somewhere it is reaching its minimum voltage. Okay. Once it is reaching the minimum voltage, from there only it is increased. From there only it is increased. Can you see that? It has to reach the minimum voltage. Like 0 0.3 for germanium, like semiconductor, you take minimum voltage is 0 0.3 volt. 0 0.3 volt. Silicon, like semiconductors, you take 0 0.7 volt minimum voltage. So once it is reaching that minimum voltage, only then it keeps on increasing the current. Until then, it won't. So that is the idea given here. That is the idea given here. So these are the three common graphs you have to remember for ohm, current, voltage, IV graphs. IV graphs. Okay, fine. So we wrote the previous part, right? So let's copy from here. Let's copy it down. From here, you are going to write. Okay. From here, you are going to write, and this is the common graph. After that, you can draw these three graphs. These three graphs you can draw. Finish drawing this part. Done, right? If you haven't done, can you please take a screenshot on that? Take a screenshot on that, please. And now, what I'm going to do, okay? I'm going to send you some questions now. I'm going to switch off and up the meeting now. I'm going to end up the class now, okay? But meanwhile, I'm going to forward you some questions at the moment because you might not be having time to do during the classes during your school hours and all. Okay, so during the weekends and also, what do you do this half an hour time you are going to use for that? You understand? So tell me first, did you understand the lesson today, guys? Sorry, this is that lesson clear? Sorry, you understand? Okay, good. So I'm going to switch it off now and be there into your WhatsApp group. You will be getting a sort of questions. Okay, so where you have to write answers now and you have to forward the answer sheet. You have to send. You understand? By 10 o'clock, you have to send me the answer sheet. Clear about my point? Clear, right? Okay, shall I end up now? No questions? And Sharin, I have sent that link to join the virtual classroom. So please make sure you are joining that. Okay, this is already there. So they are, yeah, the resources will be forwarding them. Okay, so see you then for now. Make sure you complete the answers and by 10 o'clock you have to send me. Okay, I'm ending on. Shall I? Okay, see you then. Bye.